welcome back to our Python class, and today we will talk about the second major application of machine learning, clustering. By comparison to our previously discussed classification task, where we know some answers and we want to build a model which will predict more answers. Here we pretend, or maybe we don't really have any answers, we want to group the data into some sort of grouping, basically, right? So basically to find some structure in underlying data which can be used for interpretation, basically. And again, maybe you want to do some market segmentation, again, many different uses for this. But the key part, this is unsupervised. So meaning you don't provide the answers. You let the machine do something, actually. You let your computer do something. And I hope I'm still recording. I am. So yeah, so this is the second. So automatic grouping of similar objects into sets, right? But since we already did classifier with irises, we will do the same thing with a clustering application. So clustering algorithms. So let's try it. So let me make a new notebook. Since we already have the data, clustering irises, right? And IPyNB, right? All right. Will do. Right. So clustering algorithms, clustering in machine learning. Right. What is clustering? What is clustering? Right. What is AI? Right. Unsupervised learning, like I said, finding groups in data. What else? That's it. I guess that's it for now. Right. There are different. Right. K means clustering, which is in fact, that's the algorithm we will start with. That's everybody starts with that one. And there are many other ones. Okay, so first steps we will use SciKit learn to perform K means clustering on the iris dataset. Thank you, AI. And so we will load it. We'll need import, right? So we won't try to predict yet. We will just basically give the answers, right? So we will need import the libraries. We will need, right? In NumPy is NP, maybe not. Yeah, pandas is PD, matplotlib pyplot is plot, on SciKit clustering import K means. Well, yes, we could load our data sets. We could load irises. This is such a famous irises data set that we don't really even need to load our own. But I will skip that part. I will actually use mine, the one I provided. So I will do load clean. So we won't use that one. That's of course that's an option, right? For these, but I think that's enough. That's enough. We'll start with that one. Right. Yes. So SciKit learn comes with some built-in data sets for exploring, but of course it's completely clean, right? So we already did some work cleaning. We'll use our own clean data set. All right. So we have data, and we will load it. First, we will load our data. Load df equals what? Iris CSV, but we don't have iris CSV, so we will have it here. Data iris data. Clean was it 3 types? Oh, this one here. This is the cleanest one. So iris data. We will need to go down, right? Iris. I think it was like this, right? Data. Iris data clean. I believe. Let's see. CSV. Ignore index. Let's see. df head. Let's see if that's correct. Yeah, that is correct actually. Okay, great. All right. So as we remember. So for this purpose, we'll keep this class in mind, but we really pretend that we don't. We will pretend that we don't have the class. Extract just the features. Extract features into NumPy array. So basically, yes. So while use. So this will be features, first 3 features, you know, as we will see, right? And we will see the first 5. Maybe I made a mistake. Let's see. Centimeters, right. So of course my AI assistant does not know about my correct names, right? CM on CM, right? Again. And of course I should have probably made sure these are all correct. Of course everything, you know, just double check, do df describe, see if all the data is fine, of course, right? 49, yeah, that looks like good. Minimum, maximum looks okay, right? I could of course do a histogram, draw a seaborn histogram, histogram using seaborn, Yeah, and of course import seaborn SNS set, maybe, right, DF histogram, 30 bins, maybe something like this. Right, that would be, you know, pretty nice, right? Just to see what's happening. Of course, as we already know, this data looks pretty decent. Of course, that these double bell curves are, of course, because of the multiple classes. Okay, but right, so this looks okay. Just make sure everything was, you know, on the level. All right, so centimeters, how many, and all that is good. Okay, now there was a key error, right? So yeah, so we fixed that, right? And now let's check. Yeah, all right, so 5.1, 5, 1.4, 0.2, is that correct? Where is it? Yeah, it is correct. Okay, so now we have our features, right? We want to basically just, and that's basically it actually. We are almost ready to go, because we don't know, again, we pretend, right? No testing, so for this purpose, we are not going to split into test and train, right? For clustering, we are not going to split, for clustering, right. So, but we'll do the elbow in a moment. For clustering, we are not going to split into train and test sets, right? Because all the data is good, right? Again, this is unsupervised learning, right? Yeah, we don't know the answers. All right. So now we need to build the model. So, and we will use the most popular clustering algorithm is k-means. The most popular clustering algorithm is k-means clustering, so we'll do this, we'll use it. So model, create model, we'll do the elbow later, create this object, of course, k-means. So yes, so in this case, or however, so this only trick, and then let's see how much time we have, we'll talk about this trick in a moment, is that we are using number of clusters 3. So we cheat a little bit, since we know there are 3 species of irises. So that's the only, again, the only thing is that later on we'll see that it's not always so simple, right? So let's create our model, right? Again, it's a type k-means, right? Right, of course, it is basically a clustering k-means model, right? And then we can do fit, perform the fit, perform fitting, right, this is going to be fit features. That's as simple as this. This is where the magic happens. This is where the magic happens, of course, right? All right, and right, actually it performs, it has something, something happened, of course. Now show the results, and of course k-means labels, right? So now our model is initialized, right? Of course, this will print all of them, right? Okay, we print all of them. Right, as you can see, 0, 0, 0, 0, 1, 1, 1, 2, 2, 2, 2, 1, 1, 1. Okay, from the remember, these are just magic, you know, these are just arbitrary numbers, but they represent some sort of clustering, right? So cluster 0, cluster 1, cluster 2. So the results, right? And again, so the results. So we have 3 clusters. The labels, yeah, clusters are 0, 1, right? Arbitrary numbers, you know, labels, right? But again, we can see, well, we can already see that it is not perfect, but it did, but a good start. This is a good start, right? All right. So in the following lectures, we will see how can we do any better. Actually, how to interpret this data, right? How to adjust parameters, maybe explore some more clustering algorithms. Thank you, and we will continue soon.